Okay, this problem says use the law of cosines to find the angle between two vectors. So the first thing you need to do is to sketch the vectors. So vector v is I plus j. So that means 1i plus 1j. So the x-axis is the I direction and the y-axis is the j direction when you're plotting these. So over 1 up 1. Let's sketch that vector in. We'll call that vector v. All right, now let's sketch w, and it's 2i, so 1, 2 in the x direction, minus 2 in the j direction, or the y direction. And there I have vector w. Now, I want the angle between those two vectors, okay? And to find that, I can use the law of cosines. I need to have the lengths of all three sides to use the law of cosines. So I need to come up with the length of this vector here. And we're going to call that vector w. No, v, w. Let's call that vector u. All right? So how do I come up with that length? Well, if you sketch the vectors both from 0, 0, u is v minus w. U equals v minus w. If you forget this rule, you could sketch them tip to tail. So I could start at the end of v and put w, and that would mean going over 2 and down 2. And then that vector u would be the sum of these two values, you could again use the law of cosines, but it's easier to go from 0, 0. So if you're going from 0, 0 for both of them, just remember that resultant vector is always a subtraction of these two. So let's figure what is u. If v is this, w is this, v minus w is I minus 2i, so negative I, and j minus negative 2j would be plus 3j. So now I have vector u. So how do I find the angle between them? Well, I just have to use the law of cosines. And you know in your textbook the law of cosines was written a couple different ways. It was written either solved for side A or the angle A, or side B and the angle B. So we're going to call this angle A for simplicity, and we'll use that rule. And these are in your textbook. So I need to find all of these values. And B is the length of a side. So what we're going to do is we'll have this be B and this be C. So we'll just write a little b there, a little c there, and this one is our A for sides, okay? And we're trying to find that angle. So the cosine of A equals b squared, which now is our v, so we're going to say magnitude of v plus magnitude of w, that's our c, minus magnitude of u, all over 2 times magnitude of v times magnitude of c, which is our w. So you really don't need the a, b's, and c's in there. Sometimes it's easier when you're converting to use this. So now I need to find those values. You know how to do that. Okay, oops. Notice I forgot my squares. V squared, w squared, u squared. Goodness, don't forget those squares. That is really important. So finishing this up, plugging in the values, I need to know what the magnitudes of these values are, so I got to figure them out. So magnitude of v, and you learned this before, so it's the square root of 1 squared plus the 1 from there squared, which is 1 plus 1 is 2, square root of 2. I need to find the magnitude of w, and that one is the square root of, what do you think? 2 squared plus negative 2 squared, right? 4 plus 4, square root of 8. And I need the magnitude of u. So the magnitude of u. We already have u, which was v minus w, so Again, square root, what do I put here? Minus 1 squared plus 3 squared, square root 10. All right, I got all my values, now I just plug them in there. So cosine A equals, this is easy, root 2 squared plus root 8 squared minus root u squared, which is root 10 squared all over 2 times root 2 times root 8 dw. Okay, now I just have to figure that out. Well, that's easy. That's 2 plus 8 minus 10 all over 2 times root 2 times 8 is 16. 2 times, so that's 4. So 8 on the bottom. Oh, 0 on the top. Didn't need to figure out the bottom, did I? So now I know that inverse cosine of some theta, in this case it's A, equals 0, right? And what is it when you plug it into your calculator? You remember how to do that? Yeah, you do. And you get 90. So A equals 90 degrees. There, we got the angle between those two vectors. That angle is 90 degrees. So, good luck on these.